There are planets in our universe that you won't actually believe exist. Tiny planets smaller than countries on Earth, massive ocean worlds with no land, beautiful gas giants that make Jupiter look like a baby, and even planets so massive that they nearly turned into stars. So let's go on a journey exploring all the different kinds of planets in the universe. Before we explore the largest planets in the universe, let's start small, exploring the baby planets. Smaller than Earth, we have Mars and Mercury. Mercury is just 5% of Earth's mass, while Mars is about 10%. Interestingly, the surface gravity that we'd experience on Mercury or Mars is about the same, around 40% of Earth's gravity. Moving beyond our solar system is Kepler 37b. It is the smallest confirmed exoplanet that we have found. It's actually a little bit smaller than Mercury. To give you an idea, you couldn't even fit all of Asia onto this tiny planet. But we have only discovered around 5,000 exoplanets in a universe that very likely holds trillions of them. So what is the smallest planet that could possibly exist? We ran a simulation to find out. Let's assume that this tiny planet needs to be in a clear orbit around a star and achieve hydrostatic equilibrium, meaning it's roughly a spherical shape with no big lumps. Using this definition, here it is. This is the smallest planet the laws of physics allow. I've named it Tinky. Tinky is less than 5% of Earth's radius. On Tinky, a 70-kilogram human would weigh less than 2 kilograms. You could literally jump like 50 meters high. Walking a loop around Tinky would take only 47 days, and its total surface area is roughly equal to France and Spain combined. Now, I think we should go bigger. Meet LHS 1140b, one of the most intriguing super-Earths we know. This rocky world is almost 7 times more massive than Earth, yet only around 70% larger in radius. Our 70-kilogram person would weigh around 170 kilograms here. It would be possible to move around, but definitely a struggle. And better yet, this planet sits in its star's habitable zone. You could fit nearly 3 times more land area compared to the Earth. So imagine how big the continents could be. Even more extreme is TOI 849b. By looking at its size, you might assume that it's around, 4 or 5 times the Earth's mass. But it actually clocks in at 40 Earth masses, nearly the size of Neptune, but twice as massive. We think it might be the exposed core of a gas giant planet. If a planet orbits too close to its star, intense radiation can blow away the upper gas layers, leaving behind this dense core. Living on a super-Earth would be pretty tough for us, given the intense gravity. However, if life had actually evolved there, it could just look radically different. Interestingly, these kinds of super-Earths seem to be the most common planet in the entire Milky Way galaxy. And yet, we don't have one in our solar system, and we don't really know why. And here's the wild part. It's not even close to being the largest planet in the universe. Let's keep going. Next up are the ice giants. These massive worlds made mostly out of ice and rock. In our solar system, Neptune is an ice giant, around 4 times the size of the Earth, but 17 times heavier. Now consider K2-18b, an even stranger ice giant. While Neptune orbits far from our Sun, K2-18b lies within its star's habitable zone. It's nearly 3 times wider than the Earth, but has a surface gravity surprisingly similar to ours. Now recently, the James Webb Space Telescope, essentially the most powerful telescope humanity has ever made, was looking at this planet, and what it found shocked everyone. There was lots of methane and CO2 in its atmosphere, suggesting it could be a Hycean world, a planet that has a thick hydrogen atmosphere and global oceans. With no solid surface, you would simply see oceans as far as the eye could see. However, the atmospheric pressure would be enormous, especially as you dive deeper, eventually crushing any human explorers. If we ever went to this planet and decided we wanted to build a city, we would likely have to do it up in these floating clouds, where pressure is more manageable. Now, just before I show you the biggest planet in the universe, going even bigger still, we reach the gas giants like Jupiter and Saturn in our solar system. Now, although Jupiter and Saturn look similar in size, Jupiter is actually 3 times more massive. In fact, you could combine all of the other planets in the solar system, and Jupiter would still outweigh them all. Now, for the biggest of the big, the super Jupiters. Meet ROXS 42BB, one of the strangest names I know. This planet is one of the largest planets ever detected. It's about 2.5 times wider than Jupiter and weighs nearly 9 times as much. This is actually about as large as planets get, because once they grow beyond a certain mass, its own gravity compresses it into a denser object rather than letting it expand further. At this point, the more mass you add, the smaller the planet actually gets. Typically, this maximum limit is around twice the size of Jupiter, though young planets still radiating heat might puff up a little bit more. In this case, it is still glowing hot from formation, over 1600 degrees Celsius, so its size is likely inflated. You could line up 50 Earths along this planet's width. There is another one of these super Jupiters, but it has this terrible name, so I'm not even going to try and pronounce it. What makes this one special is it's only about 200 million years old and has a magnetic field 4 million times stronger than the Earth's. This means it's covered in these massive, beautiful, planet-wide auroras. It doesn't even actually orbit a star. It is known as a rogue planet, wandering the galaxy all alone, searching for a friend. Now, despite its similar size to Jupiter, it actually weighs 13 times more. So a 70 kilogram person would weigh around 1500 kilograms there. Now we are entering a region where the line between a planet and a star starts to become blurry. Typically, anything below 13 Jupiter masses is called a planet, while anything above 80 Jupiter masses is a star. That leaves a gap in between, often called the Brown Dwarf Desert. Brown dwarfs are sometimes called failed stars because they are not massive enough to ignite sustained hydrogen fusion, though they can fuse things like deuterium for a brief period. But the thing is, these rules are not hard limits. It's very much still up for debate. A great example is this planet, Coro 3b. It's about the same physical size as Jupiter, but 22 times more massive. Is it a giant planet or a brown dwarf? We aren't really sure. It really does blur the lines because we aren't sure how it formed. Stars and brown dwarfs actually both form when clouds of gas collapse due to gravity, forming the star or the brown dwarf. But planets, on the other hand, form out of this rocky debris and gas that's in the area around these newly formed stars. This planet is really confusing because it's extremely dense. I mean, more than twice as dense as lead, but it's still made of gas and there's no solid surface that you could walk around on. How can that even be? When I first learnt about this, I didn't believe it because I didn't understand the physics. But the reality of it is even crazier. The answer lies in the extreme pressures that are deep within these objects. Hydrogen, which is normally a lightweight gas when it's here on Earth, gets squeezed down so hard that the electrons are literally forced out of their orbits, forming metallic hydrogen, an exotic state of matter that behaves more like a liquid metal than a gas. So what should we take away from all of this? Well, planets and stars really aren't that different after all. A planet is really just an object that didn't gain enough mass to become a star. We have traveled from the tiniest possible worlds like Tinky all the way to the absolute limits of physics, where we find these gas giant behemoths that challenge our understanding of physics. My question for you is, if you had to live on one of these planets, which one would you pick? Let me know down in the comments below.